Hey guys, I'm going to do a quick refresher on how you solve systems of equations. Before I do the ones at the top, let me just kind of give you the idea behind systems. We have a few fundamental rules in algebra that are always true. If I have an equation like 2 plus 3 equals 5, right? That's a true statement. I think we all agree with that. The rules of algebra tell us that we can multiply or divide this equation by anything we want, and it'll stay true. For instance, I could multiply every number times 4. If I did that, I would get 8 plus 12 equals 20. That is another true statement. So as long as you multiply every number in the equation, the result will be another true statement. So keep that in mind when you're solving things. Something else, if I say that 2 plus 3 equals 5, and maybe 6 minus 4 equals 2. Just making something up. The rules of algebra tell us that we can add or subtract any two true statements to make a third true statement. So what do I mean by that? Let's start by adding. That's easier for most people. I can add these two true statements, and the result would be 8, right? 6 plus 2 is 8. Negative 4 and 3 would be minus 1. 5 plus 2 would be 7. And that is another true statement. I could also subtract. If I said 2 plus 3 equals 5 and 6 minus 4 equals 2, I could subtract. Now, subtracting is a little harder because we have to subtract the whole thing. Remember, I told you guys subtracting is the same thing as adding the opposites. And that's a really easy way to do it. Add the opposite is the same thing as subtracting. That would give us negative 4, that would be positive 7, and that would be positive 3, which checks out. So to recap, you can multiply an equation by anything you want or divide it, and the result will be a true statement. You can add or subtract any two equations, and the third equation will be the same. All right, so going into that, now this one says to use substitution, and sometimes substitution is the best way. So I'll solve a couple of substitution and a couple with elimination. If I already have like a 1x, that might be a good time to go ahead and just do substitution. Because what I could do with this first equation is add the 9x over, and I would get add the 9y over. I would get positive 9y plus 25. And what we're saying here is that x and 9y plus 25, they're interchangeable. They are the same value. They are equal. So anywhere I see x, I could plug in 9y plus 25. For instance, I could say 6 times 9y plus 25 minus 5y equals 3. Now I do have to distribute. That'd be 54y plus 150 minus 5y equals 3. Combine like terms, I would have 49y. Move the 150 over equals negative 147, so y would equal negative 3. Now what I can do with that is plug in the negative 3. So x equals 9 times negative 3 plus 25, so x equals negative 2. And so negative 3 and negative 2 would be my solutions. That's the coordinate. Negative 2 comma negative 3, or you could just leave it separate. Either way. How do we feel about that? Pretty good? I'm not a big fan of that sort of thing, so I'm going to kind of leave that alone. This next one, I'm going to leave that one alone as well. Let me see here. Here we go. Elimination. That's what I want to do. This is what I like doing. And I do this most often with these type of situations. I have two equations. First off, these are pretty straightforward. You want them in the format ax plus by equals c. We're already in that format. We're already in ax plus by equals c. It's already like that. So we're in good shape. Now, we talked about how we can multiply and divide by anything we want to a single row, or we can add or subtract any two rows. So the goal here is to get your coefficients for either the x's or the y's to be the same number but opposites. What do I mean by that? Well, if this was 6x and this was negative 6x, when I combine them, wouldn't my answer be 0x? And that would eliminate, that's what elimination means, it would eliminate one of my letters. Let me just kind of play it out. I think it's easier to understand if you see it. So I'm going to multiply this row by 2. Why? Because the first number that 3 and 2 both go into is 6. So multiply everything by 2. You get 6x, you get 22y, and you get 8. I'm going to multiply this row by 3. That would give me negative 6x, negative 18y, and still 0. 3 times 0 is 0. So you have to apply it to the entire row. Now I can combine these two rows. So the x's cancel out. 6x and negative 6x. It's a fight to the death. Nobody wins. Here we have 4y equals 8. So we know y equals 2. 22 minus 18 is 4y. So we added the two rows together and we were able to solve for y. Then we go back and we plug in to solve for x. 3x plus 11 times 2 equals 4. I just took this equation and I plugged the x number in. I plugged the y number in. So 3x, that'd be 22. 4 minus 22 would be negative 18. X would equal negative 6. So there are my solutions. That's pretty fun, right? Right, guys? Yeah, I think so. All right, let me do another one. I'm just going to pick a random one. Some of these look easier than others. All of these look... There's nothing too crazy here. Okay, I guess it doesn't matter. I'll pick this one. What's the easiest thing to transform? Well, I could make my x's match real quick. If I multiplied this entire row by 3, I would get 9x minus 6y equals 6. And that top row, negative 9x plus 5y equals 1. These are going to combine real easy. Negative 9 and positive 9 eliminate each other. Negative 6y and positive 5y would be negative y. And then that would equal 7. So positive y would equal negative 7. So what do we do next? We plug in that value. So negative 9x plus 5 times negative 7 equals 1. I just took this equation and I plugged in the negative 7 for y. So negative 9x, that would be negative 35. Added over, that would be 36. So x equals negative 4. There's my solution. So you will have to solve some systems, guys. Let's see here. I don't have any good examples here for what I was wanting to do, but there will be some systems to solve for sure.